Hello, everyone, and welcome to the Temporal 3 podcast, where we talk all about fire alarm. I am joined by my co host today, Mr. Charles Aulner. Hello, Charles.
Good day.
Good day. And Mr. Chris Godwin. Hello, Chris.
Hey, Brian.
So, I'd like to start out today talking about certifications, particularly about multiple certifications. So, in classes recently that I've taught, and Chris, I know this has happened to you, and Charles, this has happened to you as well. In fact, Charles, I know, and you and I have followed this guide. I've experienced students who have experience in multiple areas. And even though they were in a fire alarm class, I encouraged them that if they had sprinkler experience or special hazards or now ERCCs, to seek additional certifications. Chris, what's your opinion on seeking multiple certifications?
The more certifications you have, it makes you more valuable to the company and more marketable for projects and everything else. If you've got somebody that's got several different certifications, you don't have to outsource for that stuff. So it actually makes it so that you're able to get more jobs, more contracts, more money, more money, more money.
More money, more money.
Yeah.
Charles, how about you?
Well, the big deal, in my opinion, isn't the certification itself. It's the training and the knowledge, developing yourself as a professional in our industry. The certification represents your efforts in that regard. But the knowledge that you gain and being able to apply that knowledge in the industry is really the key benefit. The certification is important, but being able to take the knowledge that you've learned through that certification process and applying it is really where the rubber meets the road, in my view.
Absolutely. I like to say the more acronyms you have after your name, the better your opportunities are. And as Chris said, you framed it great from the employer perspective. As an employer, I would definitely want my people to be certified in different areas because it opens up opportunities for other jobs. You go to do a job, and particularly as big as ERCCs is becoming, and NICET ERCCs certification, or as they call it, IBPSC, is starting to gain some traction. And if you're ahead of the curve and you have that ERCC certification, now that puts the company ahead and being able to bid that project, particularly if the AHJ or the project requirements, the specifications call for it. Now you've got it. It gives you a leg up.
Well, another thing
It
it does
definitely
too,
helps. I mean,
Brian. Go ahead, Chris.
I was just going to say, a lot of companies they do fire alarm, but they also have other things. Other low voltage, such as intrusion, such as doing inspection testing for sprinkler systems, doing special hazards. And if you've got those acronyms, you're a lot more capable of being that tech that is able to work on all of those different systems. You have to have specialized training, and in most places, most jurisdictions, you can't touch it without some kind of the qualifications for it. So having that behind your name, absolutely, it gives you a lot more access to being able to do much more.
Charles, you were going to say?
From the employer perspective, one thing it also does is it tells me as an employer that this person has the knowledge to do things right. And I can't tell you how big of a worry it is for employers that they're going to hire someone who's going to go out there and make some sort of a huge mistake that's a liability or a risk to the company. So hiring someone who has documented certification gives the employer some insurance or assurance that, hey, this guy's going to be out there doing things the way that I want it done. He's not going to get me or my company in trouble.
Yep, exactly. So from the
He or
NICET
she.
from the NICET perspective, yeah, there we go. We want to be politically correct. From the NICET perspective, it's an important consideration should you seek multiple certifications that you document that from the get-go. Chris, how does NICET want to see your documentation, your work history? Do they want it piecemeal or do they want it all at once?
No, they want everything. They want everything all up front at once from the beginning up to current time, which can be kind of difficult when you're looking at going across different fields because if you put down that you have 100% of your experience in one field, okay, well, that means you have zero experience anywhere else. And so it gets a little bit tricky, is what I would say when you go to look at the documentation process. But absolutely everything, document everything that is your work within that field or any fields.
Absolutely. You definitely want to give them the full boat, give them and consider too, like you said, Chris, if you said you're 100% fire alarm for the past 10 years, and later you decide, okay, well, I want to go for that sprinkler certification because I have some sprinkler experience, you can't restate history with NICET. You can't say, okay, I didn't tell you guys the truth from the get go. I actually had about 50% of my time in sprinkler, so I want to change that. NICET will find that unacceptable. Well, next thing I'd like to talk about today, guys, is smoke control. Smoke control. What is smoke control? Well, smoke control controls the movement of smoke and air within a building to maintain a tenable environment for the occupants so they can exit. Smoke control is kind of a peripheral type of thing to fire alarm. And a lot of times, smoke control systems will integrate with fire alarm, and we do get occasional questions about smoke control, but it's actually a completely different set of codes that govern it, different parts of the building code and NFPA 101 that govern it. Chris, what has been your experience with smoke control?
From the field, you got to watch out when you're going to do any kind of testing and everything, because if you're not aware that you have a smoke control system in the building, you might be testing smokes at a mall in the middle of winter and wondering, why is it so cold inside? It's winter time. Well, you activated the smoke control system unknowingly. So they're my experience with them is they're actually really cool with how the whole setup works and what it is that they're actually doing. So in the event of a fire, you're pressurizing certain areas and exhausting other areas so that you are keeping the smoke away from places that are going to be exit areas for the occupants of the building. When it goes off, it's actually really cool once you're aware of it.
Once you're aware of it, exactly.
Yeah,
Well,
yeah.
I guess because the code requires an FSCS, you didn't realize there was an FSCS, firefighters command station, smoke control station rather, in that mall.
More or less, I didn't realize, like, we knew it was there, but it was one of those things that new to the field, and it didn't pick up on, hey, if you do those ones, we need to reset them because
Right.
it's winter time. Otherwise, this building's gonna get a little cold.
Well, and you're from Vegas too, Chris. I didn't realize it actually got cold in Vegas.
It gets cold. It gets dry cold, is what it is. The temperature is not low, but the air just cuts to the bone.
Yep. Still windy.
Yeah. Yeah, and you pumping all that into a building when it's supposed to be warmer, eh, people get uncomfortable. And why is it so cold? I don't know. No idea.
Charles,
All
what
of a
has been
sudden, everything's lit up. Yeah.
Charles, what has been your experience with smoke control?
Well, typically, is from a fire alarm perspective, we interface. That's what we do. Uh, Whether it's duct smoke detectors or something else, we provide an interface. So we're not really that much involved in it, but the concept is really cool. In high rise buildings, Chris mentioned pressurized stairwells. Uh, we put higher pressure in the stairwell so when the door to any floor is open that might have smoke, that high pressure blows from the stairwell into the room to keep smoke out of the stairwell. The stairwell's an exit path. Uh, Having that clear of smoke allows people to exit without choking. So the
Absolutely.
concept of that is really cool, I think. Uh, it's a specialized field. There are people
Yes.
who really work just in smoke control. Um, I I think it's an integral part of a fire protection plan for a building.
Well, it's also an integral part of the NICET exam because if you're taking the INT FAS exam, the inspection and testing of fire alarm systems, at level 2, they allow NFPA 92 in, which is the standard for smoke control, and they will ask you questions about smoke control. Now, it is based on chapter 8 of that book, which is testing of a smoke control system, and there are some things you have to test and the way the tests have to be done and all that stuff. but it is something you need to be aware of. And even in the main fire alarm exams, talking to students, I've talked to a lot of students that in the main fire alarm exam at level 3 and level 4, they'll see questions about smoke control, not about the engineering of smoke control, because that is an engineered system, as Charles said. There are people that is their field. It's very specialized. But from IBC Section 909, which covers smoke control requirements and actually dictates that. I found this one really interesting. And the student asked me the question. I had to look it up in the IBC. The color of the LEDs on the FSCS. There's actually in IBC 909, it tells you what color the LEDs have to indicate on the FSCS. And he saw that as a question on his exam. And I thought that was really interesting. So, yeah, we want to be aware of 909 for level 3 and level 4 in fire alarm system. So, guys, is there a reference available from NTC that talks about smoke control?
I mean, we talk a little bit about it within the confines of the Brown Book
Yes.
as it ties into your fire alarm systems. So a little bit, just a
Yep.
little bit in there.
We do have an entire chapter, chapter 19. Now, it isn't a 20 or 30 page chapter. It's about 5 or 6 pages, but still,
Yeah.
it is designed to give fire alarm people a fundamental understanding of smoke control and applicable codes, because that is the kind of thing that NICET may ask you about on the exam.
Yeah. I do like that the smoke control code book, NFPA 92, is just such a big book.
Yeah.
It's just such a big code book. There's just so much to it.
Yes. Just like, and it's about the size of NFPA 70, right?
Right. Yeah. Yeah. The smoke control code book is just it's a small book, and like you said, Brian, most of what we're looking at is chapter 8 materials for the testing inspection side of it. But easy to navigate once you get a little bit of that feel for it's an NFPA book.
Yep.
So
Absolutely. So, our question from the field for this session is end voltage versus a voltage drop calculation. Charles, you have a little bit of experience with this from my career in distribution, your career with a installing dealer. You want to tell that story about voltage drop?
My gosh. Yeah, it's a practical application from the field. I was on a project, and the horns at the panel sounded fine, but the ones at the end of line sounded sickly, to say the least. The flash rate of the strobes was off. I was having severe problems. So I went to my local distributor, where an expert on this subject happened to work,
Yeah.
to seek out some advice. Brian, that said expert, can you tell me what advice he gave me?
Yeah, he told you that, hey, dumbass, you need a NAC extender or you've got a voltage drop issue. Either need to pull bigger wire or split the NAC circuit or buy a NAC extender. I think you actually ended up buying a NAC extender, which of course I overcharged you for because you didn't know
My
what you were
gosh,
doing.
that's true. And your advice as an expert was worth the price.
Yes, it was. So, Chris, what's the difference between a voltage drop calculation and an end voltage calculation? How do they differ? And particularly in the NICET exam is something that you may see this.
well, both of them involve doing a voltage drop calculation. And what voltage drop is it's the loss of voltage along the circuit. Whereas the end voltage is what the last device is actually receiving. In the NICET exam, you gotta watch out when it comes down to the questions, because what is the question actually asking? You'll have answers for both, and if you don't do the entire calculation, you're left answering with just the voltage drop, which will be a lot of times one of your available answers. That's not necessarily what they're asking. You got to make sure. So with voltage drop, we're looking at Ohm's law, E equals I times R. We're looking for the loss of the voltage. So we're looking for E. What we're looking for with the end voltage is what's left after. What is left after at the last device? And that actually is a much easier calculation once you have voltage drop done. You're just taking what you're starting with and removing the drop. So it all comes down to what is the question actually asking?
Yep, absolutely. And I'd like to give it an example of that. If we have, and it's something that you may see on your NICET exam, and how the equation can go both ways for us. So NICET may ask you a question about 500 feet of 18.2 on a 24-volt fire alarm panel with 1 amp current. So first of all, we have to realize that 500 feet of 18.2 is 1,000 feet of circuit length. It's 500 feet out, 500 feet back, because voltage drop is all about how far the electricity travels, not about the length of the cable. We need to differentiate between cable length and circuit length. So 500 feet of two conductor is 1,000 feet of circuit length. We'll go to NFPA 70, Chapter 9, Table 8. We'll see the value is approximately 8 ohms, as Chris mentioned. We'll do an Ohm's law calculation, E equals I times R, and I like easy math, so I'm using really simple numbers. Current is 1 amp, I is current. Current is 1 amp, ohms, R is resistance, 8 ohms, 1 times 8. The drop on that circuit is 8 volts. However, NICET could also ask us about that same circuit, what is the end voltage, the theoretical voltage at the last device? So that requires an additional step, as Chris mentioned, where we take our starting voltage, which is 24 volts, we subtract our drop, which is 8 volts, and that gives us the end voltage. So for the end voltage on that circuit, that would be 24 minus 8, which would be 16 volts. And as Chris said, it is very likely that you're going to see both 8 volts and 16 volts, and maybe some other options as well, because there's always 4 answers on the NICET exam, other options as well. And if you are not careful in reading that question, depending on how they ask you, whether it's end voltage or voltage drop, that's a relatively simple calculation that unfortunately you could get wrong. Do we see this a lot in class, Chris? Do we see this in our practice test and stuff like that?
We put it in our practice test on purpose.
But I mean, do we
We
get
do it on
questions
purpose.
from
Just, but
students about
yeah,
this? Yeah,
absolutely. We get students that will go about it and like, how did I get this one wrong? What are we asking about? What is the actual question going for? And you got to be careful. You got to be careful. You got to know the difference between the two, and you have to read the whole thing. And that is one of the things that in the NICET exam under pressure, you're trying to get through quick. So sometimes we miss that. What is end voltage as opposed to, all right, I've looked at everything for the voltage drop calculation. I've already done that. And oh, there's my answer. On, pump the brakes. Easy enough question. Take that extra second.
Charles, how do we react to our students when they ask questions like this? Do we say that's a dumb question?
Absolutely not. We take them through it step by step. You talked about it. Uh, it's really important in learning how to do this that you see it written
Yep.
out.
Yep.
So that's really a critical thing. And the application of this really comes in with fire alarm design. When we set up a design for a fire alarm system, this voltage drop calculation is a critical part. And when we submit our plans to the AHJ, they're looking for this to make sure that we have the right sized wire, uh, the right power available for the notification circuits, because if we don't, notification isn't going to happen the way the code requires.
Absolutely true. So, yeah, real world application as well as code world application here. So again, knowing how to do it. And I know the thought process for a lot of people is, well, the design program does that. Okay, well, what if you're in the field and you're adding some notification appliances and you want to make sure the circuit's still going to work? Isn't it good to be able to know how to do the math, to just do a double check? Or do you always trust the program or always trust the designer that they put everything in properly? I don't. I'm old school. I like double checking things. I don't trust the machine.
Well,
Computers never make
another
mistakes,
aspect
Brian.
of that is understanding the concept. And we gain that understanding of the concept by knowing how the calculation is done. Having the program do it for you is fine, but having an understanding of the concept of how it's done is important as well. Chris, go ahead.
Absolutely.
I was just saying sarcastically, the computer never makes mistakes. Never. It's never made 'em ever. Usually when there's a mistake on the computer, it is user error, but
Yes.
on that being able to understand the process, like you said, Charles, and being able to know the how to do the calculation is huge because then you could catch that mistake before it gets past any kind of going to the AHJ, going off for bid, going off. You can catch that beforehand and say, "Oh, hold on."
Yep.
So
All it takes is a decimal point in the wrong place, guys, and that's really easy to do. Either manufacturer error, data entry error, whatever the case is. And yeah, being able to having that skill to be able to do that, to double check the computer just to make sure, going to save you a lot of embarrassment, going to save you a lot of frustration, could save you repulling a lot of wire because nobody caught the mistake along the line. Well, gentlemen, I appreciate your time today. Thank you very much for engaging in this conversation. This is the end of this edition of the Temporal 3 podcast. Please subscribe and join us for our next session. Have a great day, guys.
You too, Bryan.
Take it easy.